we have to show cos4 theta. Okay, so left hand side is cos4 theta. So we were going to write cos4 theta is 2 theta plus 2 theta. We always want to involve 2 theta. If it was cos3 theta, we are going to write theta plus 2 theta. If it is 4 theta, it is 2 theta plus 2 theta. There is not going to be sums cos5 theta or 6 theta. Is going to be confined to 3 theta and 4 theta. So this is going to be, we know it's going to be cos minus sin. So this is going to be cos 2 theta minus sin 2 theta sin 2 theta. Now here, since both the angles are same, cos 2 theta and cos 2 theta, they're identical creatures, they're the same, so we can write cos squared of this angle minus sin squared of this angle. I've mentioned that if the same thing are multiplied, we write sin square of any angle or cos square of any angle. Now what we have to express, again we have to express in terms of cos square, so you have to break this down. So cos square 2 theta is the same as breaking this down as 2 cos square a minus 1. We're going to follow the guidance of the question, so we're going to follow that. So we can write cos 2 theta as 2 cos square theta minus 1, and this whole thing is squared, so this is squared. So 2 cos square theta minus 1 squared. Of course they used a here, and here they're using theta. That's fine, completely fine. Minus sin square theta. Sin 2 theta is 2 sin theta cos theta, and we're going to square it because there is sin squared theta is the same as whole squared. Sin squared x is the same as sin x whole squared, is the same thing. So we can say that this thing and sin x whole squared, they're the same thing. So here we can use the algebra of a minus b whole squared. So a minus b whole squared is the basic algebra rule, which goes like this: a minus b whole squared is a squared minus 2ab plus b squared. So this algebraic concept can be used. For that case, a squared is going to be 2 cos squared theta whole squared minus 2ab. So 2 cos squared theta is, this is a, and b is 1, plus b square plus 1 square, minus, and this portion 2 sin cos whole square is going to be 2 square is 4, sin square is sin square, cos square is cos square. This is what it's going to be. So this is 2 cos square theta whole square is going to be 2 square is 4, cos square square is going to be cos to the power 4 theta. Remember, not on the angle but on this. That's where the power is going to happen. So 2 to the 4, and cos square theta is going to be cos square theta plus 1 minus 4. Now everything is fine except for this sin square theta. So we have to make it cos square theta, because in our proof the identity has to be completely cos in terms of cos. So we know that instead of sin square we can write 1 minus cos square. So we can write 4. Let me write the cos square theta ahead, and instead of sin square theta let me write 1 minus cos square theta. So what do we get now? So we are getting 4 cos to the power 4 theta minus 4 cos square theta plus 1 minus 4 cos square theta into 1 is 4 cos square theta minus 1 is plus 4 cos square theta into cos square theta is going to be 4 cos to the power 4 theta, and the final line is going to be, we need 8 cos to the power 4 theta. So 4 cos to the power 4 theta plus 4 cos to the power 4 theta, 4 plus 4 is 8 cos to the power 4 theta, and we are going to get minus 8 cos square theta minus 4 cos square theta minus 4 cos square theta is going to be minus 8 cos square theta, and finally there is a plus 1, so we're going to write here plus 1. So therefore the left hand side is going to be equal to the right hand side.